Hey y'all, what's up? This Tip, I'm back again. And I was asked by a request to do a video about the Eve gene. So, what is the Eve gene? The Eve gene is actually the Mitochondrial Eve. So, I have some information. Actually, I have a lot of it, but I'm not going to go through all the information, but I'll show you guys, just in case if you guys want to do the research on your own. All right, so what I'm going to do is I'm just going to first go to the Wiki1 source. Okay. And with this source right here is called the Monacondre Eve. So we're going to go into the introduction. It says in the human genetics, the Mitochondrial Eve is a matrilineal, most recent common ancestor of all living humans. In other words, she is defined as the most recent woman from whom all living humans descend in an unbroken line purely through their mothers and through the mothers of those mothers, back until all lines converge on one woman. And it also says in terms of mitochondrial haplogroups, the MRCA is situated at the diversion of macro haplogroup L into LO and L1 through 6. As of 2013, estimate on the age of this split ranged around 150 years ago, consistent with a date later than the speciation of the Homo sapien, but earlier than the recent out of Africa dispersal. All right, so then talk about the male analog to the Mitochondrial Eve is the Y chromosomal atom, the individual from whom all living humans are patrilineally descended. As the identity, both matrilineal and patrilineal MRCA, is dependent on the genealogical history pedigree collapse. They need not have lived at the same time. As of 2013, estimates for the age YMRCA are subject to substantial uncertainty with a wide range of times from 180,000 to 580,000 years ago, with an estimate age of between 120 and 156 years ago, roughly consistent with the estimate for MTRCA. Now, as you can see, it goes down here discussing how the name Mitochondrial Eve came about. So the name Mitochondrial Eve, or what you call the Eve gene, alludes to the Quranic and biblical Eve, which has to repeat misrepresentation, misconception in journalistic accounts on the topic. So popular science presentation of the topic usually point out such possible misconception by emphasizing the fact that the position of MRCA is neither fixed in time, as the position of MRCA moves forward in time as mitochondrial DNA lineage become extinct, nor does it refer to a first woman, nor the only living female of her time, nor the first member of a new species. All right, so the Mitochondrial Eve. So basically, it's just nothing more than the women who carry on the mitochondria genetics. So that means women we carry, or females, we carry the MT DNA. That's what we carry. All right, and it's only passed down from mother to daughter, and the daughter passed down to her descendant, her female descendant, and so on. Well, take that back. The mother passed it down to both her male and female children. But however, it's her daughter that only can pass it down to her daughter. See, the male can't pass down the mitochondrial DNA because he has a Y chromosome. So he'll be able to pass down the Y chromosome to his male descendants. So that's really all what it is. And also, we do represent a group called the Homo sapiens. So the Homo sapiens are modern humans. You had other humans that was around prior to that time period, like the Australopithecus, Ardipithecus, etc. They was around like million years ago, but they were not modern humans. And you also had the Neanderthals that was around too. The Homo sapiens are the only modern human beings that's still around to this day. And what's also interesting is that the Homo sapiens also carry some Neanderthal genes as well. So if you ever took the ancestry test, and for those who took 23andMe, and I think what's it, the National Geographic, and I forgot the other one. But if you took any of those tests, you would notice that they show that you have a Neanderthal gene. And I can give you an example by showing you my results. So I can pull up my result that will help better explain that. So let me go ahead and let me put up my 23andMe. All right, so you guys, I'm going to show you my DNA result to help better explain this, all right? So right here, I'm on my 23andMe website. Okay. As you guys can see, all right, that's my home page. Now let's go to where it says, I think it's under traits. Let me see. Let me see for a moment. Is it under traits? No, I don't think it's under traits. Let's see, all DNA, all ancestry report. Okay, here we go. Let's see, right under here. All right, so right here, now it shows that I have what is called the Neanderthal gene, as you have more Neanderthal DNA than 1% of other customers. Now, what it shows right here, and I know it's kind of getting off the subject, but says, what does this mean? You have 2%, less than 2% Neanderthal DNA. You inherit a small amount of DNA from your Neanderthal ancestors. Out of 7,462 variants we tested, we found 41 variants in your DNA that trace back to the Neanderthals. All right, so the Neanderthal was another group of humans, species, right? And they weren't really, their lineage is not really found in Africa. It's more so found in what we know today as Eurasia, which is the Europe and Asia area. So it has been said that the Homo sapiens and Neanderthal has been mating with each other before the Neanderthal has became extinct. So the Homo sapiens and Neanderthal was made with one another, and that's why as humans today we carry on those Neanderthal genes. All right. All right, so let me get to the other part of this. Let me explain to you about my mitochondria. All right, so right here, it goes to the maternal haplogroup. So with the maternal haplogroup, it's going to look at the matrilineal, means the female side of the family. So because I have a double X chromosome, right? Due to the fact that I carry a double X chromosome, they only going to go by my matrilineal side. So right here, it says, you descend from a long line of women that can be traced back to Eastern Africa over 150,000 years ago. These are the women of your maternal line, and your matrilineal haplogroup sheds light on their history. All right, so right here, as you can see, it says, as our ancestor, or as a matter of fact, before I go there, it says my haplogroup is L3D15. So L3D is like somewhere around East Africa. All right, so that's my haplogroup. That's my earliest ancestor. Just put it in a nutshell. All right. So Now, it's going to be a whole lot to talk about the subclades and all this other stuff, but this is my haplogroup right here. All right, and it says, as our ancestors venture out of Eastern Africa, they branch off into diverse groups that cross and recross the globe over tens of thousands of years. Some of their migration can be traced through the haplogroups, families of lineage that descend from a common ancestor. Your maternal haplogroup can reveal the path followed by the women of your maternal line. All right, so right here it says that my haplogroup, which is the L, has been discovered around 180,000 years ago. Okay. So it says, if every person living today could trace his or her matrilineal line back over thousands of generations, all of our lines would meet at a single woman who lived in Eastern Africa between 150,000 years and 200 years ago. So therefore, this single woman was a Homo sapien. All right. Yes, that's right. Yes, that's what I'm talking about. That's what I'm talking about. Yes, everybody. Okay, here's the thing with the Monacondrial Eve, right? Which is the mtDNA. Every woman has that. Every woman has the Mitochondrial Eve DNA. All right. So how can I say it? Yeah, every woman has the mtDNA. Every woman has it. So, however, it's just very significant with us African descendant women. It's very significant because of the fact that we not only are African descendant as far as like the West and Central African ancestry is concerned, but also when you look at their ancestry, right, you will see their ancestry come from the eastern part of Africa. So with that being said, every woman has a mitochondrial DNA. It just depends on like what region, what part of her earliest ancestor came from. So some places are different, but if we're going to speak fundamentally speaking, technically, all humans are considered as African because of the Homo sapien family. Technically speaking, as far as fundamentally. Now, directly speaking, as far as your recent ancestry and your direct bloodline, is different. So you got those who have ancestry come from Europe. You have ancestors that come from Asia. You may have those who got ancestors come from Africa, eastern part of Europe, western part of Europe, etc. It's very complicated to explain this kind of stuff because it's like you have to really get deep into it. But I'm trying to explain the best way I know how. So yes. But at the end of the day, we all come from Homo sapiens. And what happened was with those group of Homo sapiens, many of them dispersed out of the continent and went to various parts of the world and to create their own offspring. And then they came back into the continent of Africa and made it with their offspring there, particularly those who carried the Y DNA. I mean, even though you had some few mitochondrial DNAs, but more so it was coming with those who had the Y DNA because they was gathered hunterers and they had to travel out so much. Also, what else I wanted to say? What else I wanted to say? Good God Almighty, I forgot. So, yes, I wanted to say also you would notice that there is a lot of admixtures going on. So when you take these ancestry tests to show and prove that the bat migration and admixture taking place, let me show you mine once again. Then I'm going to come back to this, explain this. So I'm going to show you my ancestry composition. All right, so this is my ancestry composition right here. That's a picture of me. So right here, it says sub-Saharan Africa. Sub-Saharan African would be like the lower part of Africa, right? Right here in this little region, if you can see this little map over here to my right. Now, the upper part of it will be considered as the Saharan, but the lower part is considered as sub-Saharan. All right. Now, right here, it says West African, 78.6%. And as you can see where my genetics are, according to this information, I have about 41.6% Nigerian. The ancestry is like 21.8% from Ghana, Liberia, and Sierra Leone, Senegambia and Guinean, 5.3%, broadly West Africa, 9.9%, which is like the other regions. And then, of course, if you look at the Congolese in southern East Africa, which is like in the center and the southern part of Africa, right here, 11.8, Angolan, 10.6%, southern East African, 0.5%, broadly Congolese and southern East African, 0.7%. Now, also right here in Northeast Africa, 0.1%. Right in that region, broadly Northern East African, 0.1%. Broadly Sub-Saharan African, 0.2%. All right, so I know it's kind of complicated to read this kind of stuff. Now, if you know, is where it says European. So according to this test, and this ain't the only one I took, I also took Ancestry too. I have some European descent. All right, I only have a small percentage of it, which is 8.6%. Now, it shows that I have Northwest European. What is the Northwest European? Which is at 6.9%. That is, Northwestern Europeans are represented by people from a far west as Ireland, as far north as Norway, as far east as Finland, and as far south as France. Okay, that's Northwest European, of course. Also, it says your DNA suggests that 6.9% of your ancestry is British and Irish. So what I'm just showing you guys is the example of how the admixture taking place and the Bantu migration and all that stuff. But as you can tell, some of this you could tell is recent because a lot of it had to do with slavery of our ancestors, and there was those who had interracial relationship. There was those who were raped by their slave masters and whatnot. So you had British that owned slaves and Irish people that owned slaves as well. So yeah, but I just wanted to give that example. Also, what the heck? Okay. Also, you can see down here it says broadly European, and then they trace some ancestry. There's a possibility I got Filipino, Native American, which is at 0.2%, which is not that much. It's a very small percentage. So I'm just showing you how the migration admixture work. Even those who are predominantly European or what we call white people, they got some form of African admixture in them too. They may not have a high percentage of it, but they have some African ancestry. Why? Because of those African ancestors who made it with those Europeans. And then, of course, if you go further back into history about the Homo sapiens and the admixture, the relationships they had with each other, etc. All right, so let's look at all ancestry report. Let's go back. So let's go back and explain my mitochondrial haplogroup. All right, so right here, the subclade is the haplogroup L3. So here's the branch of L, which is the haplogroup L3, which arose from a woman who likely lived in Eastern Africa between 60,000 and 70,000 years ago. While many of her descendants remain in Africa, one small group ventured east across the Red Sea, likely across the narrow Bab el Mandeb into the tip of the Arabian Peninsula. So again, going to show you the Bantu migration. So this ancestor, who was the L3 ancestor, was not only living in eastern part of Africa, but also had descendants that eventually venture out to different parts of the Red Sea and in the Arabian Peninsula. All right. So it's in East Africa, right? And of course, 26,000 years ago, the L3D group, what is the L3D group? Um, It says your maternal line stems from the haplogroup L3D, a branch of the L3 that arose in Western Africa about 26,000 years ago. So therefore, the L3 went over to Western Africa, right, about 26,000 years ago, and they populated and created offsprings there. So, and it says, like many haplogroups found in that part of Africa, it spread widely with the migration of the Bantu-speaking people. So the Bantu-speaking people are located in what we know in the southern part of Africa. So in the southern area, like Tanzania, Mozambique, and those regions. Yeah, that's where you find a lot of Bantu speakers at. So anyways, it says it's spread widely with the migration of Bantu speaking people that began approximately 4,000 years ago. So L3D is now found at high levels among the Bantu speaking Sukuma of Tanzania and is quite common in Mozambique. Due to the importance of Western Africa in the Atlantic slave trade, it is also found among African Americans. Very common, like I showed you in my DNA. So now, right here, it goes into the L3D15, which is 26,000 years ago. So they don't have much information on it, but it says that's nearly 1,040 generations ago. What happened between then and now, as researchers and citizen scientists discover more about your haplogroup, new details may be added to the stories of your matrilineal line. All right, so they don't have enough information on the L3D1-5. All right, they don't have that much information, but I can probably speculate that, of course, they came from the eastern part of Africa and migrated somewhere along the western part or the central part of Africa. That's just my speculation. All right, so of course it goes into the concept about the Bantu migration. And of course, it shows the mitochondrial DNA. All right. Okay. So that's that information. I mean, it's a lot that you got to really go into. It will take all night. But yeah, just to give you a general idea of how this works and how the whole mitochondrial DNA thing and the haplogroup thing take place. So how it all boils down together. So yeah, it's really a lot to go into. It really is. It's really a lot of information. But I hope you guys get the gist of that. So now I'm going to show some articles. Let me show the article about scientists think they found Monacondre Eve's first homeland. Okay, let me see this. All right, so this came out in October the 28th of 2019. Now it says scientists think they found Monacondre Eve's first homeland. Today is a desert 200,000 years ago. Perhaps it was home. And what do you see? The sand people, right? And what do we know about the sand people? Let's find out. Let's find out who are the Sand people. Now, the Sand people are one of the oldest tribes in Africa. Okay. Now, are they part of the Bantu family? That part, let's see. Hold on, let me, cause see again, you gotta really go into this. Okay, so the sand Bushmen, also known as the Kiwi Shoal or Bashara, are the oldest inhabitants of Southern Africa. They are part of the Khoisan group. All right, they're part of the Khoisan group. Isn't it interesting? Just want to show y'all that. But let me go back to the source. So it says 200,000 years ago, the earliest shared ancestor of every living human on Earth rested their feet at a verdant oasis in the middle of Africa's Kalahari Desert. So going down, genetic Eve. So it says the LO lineage is a sequence of DNA encoded solely in mitochondria, a small structure in your cell that turns food into cellular energy. And the mitochondrial DNA accounts for a fraction of your genome, with the bulk of your DNA locked away in cell nuclei. However, while nuclear DNA is inherited from both parents and recombines with every generation, mitochondrial DNA is solely from your mother and can remain unchanged for tens of thousands of years. As such, mitochondrial DNA, also known as the mitogenome, is a key tool for tracking genetic history. All right, so as you can see, it says L0 is especially important in that regard, as all living people are believed to descend on their maternal line from the woman who first carried the sequence, a hypothetical woman called Monacondre Eve. Today, the LO lineage is found mostly coming in the Khoisan people, two indigenous group living in Southern Africa. Numerous other groups of indigenous Africans carry mitochondrial DNA that descends from this lineage, but with subtle variation. By comparing those variations from groups to group, geneticists can piece together a general timeline of when these ancient genetic lineage diverge. So, all right, so as you can see, the article kind of to like go into detail and then goes into these two oldest group in South Africa. One is the San people and the Khoisan people. So you guys can check out the information on livescience.com. And this came out in October the 28th of 2019. All right, so also you can also find out more information on this website called The Ancient Origin. So it goes into the genetic Adam and Eve. All humans are descendant of one man and woman who lived over 100,000 years ago. All right. So right here, it says Mitochondrial Eve. A similar analysis has also been conducted to trace back a common ancestor of all women known as Mitochondrial Eve. The DNA from mitochondria, the energy center of a cell, is carried inside a female's egg. So only women pass it on to their children. The DNA held inside mitochondria can therefore reveal the maternal lineage to ancient Eve, who is believed to have lived in Africa between 99,000 and 148,000 years ago, almost the same time period during which the Y chromosome Adam lived. All right. So you can go on ancientorigin.net and you can find out more information. All right. So, shit. Also, you can check out this website right here if you're interested. It's called the E Gene. All right, so it's on Shades of Noir. Shades of Noir, which is a French word that means black. Okay, and this was written on August the 10th of 2020 by Shanice Adamson. So you can look up this information yourself and do some research on it. There's a book I think is very interesting. If you guys don't have it, you need to put it on your PDF, or you can check it out on Amazon. It might seem a bit controversial, but it will make sense. It says, "Everyone is African. How Science Explodes the Myth Erased" by Daniel J. Fairbanks. So you guys can go ahead and check that out for yourself. All right, so then here's an article here called "The Journal of Blacks in Higher Education." And it's called the African Eve, new confirmation that we all came from Africa. They call it the African Eve. This was back in 2001. That was about 20 years ago, 21 years ago. So, you guys want to check this out? You can. All right, so check this out right here. I'm going to read a little bit. It says, "The so-called scientific racists of the school of Louis Agassiz, Arthur Jensen, and most recently Jane Watson have taken the position that Black people are not only a breed apart, but also genetically inferior in intelligence to whites." Accordingly, the scientific racists have always put their efforts behind constructing archaeological evidence that Negro was a subspecies of human beings who developed geographically apart and along completely different anthropological lines from whites. It is generally agreed among anthropologists that Homo sapiens' original ancestor, Homo erectus, developed in Africa about 2 million years ago. Even as scientific racists conceded this point, it is also generally accepted too that Homo erectus migrated throughout the eastern and western hemisphere and evolved into many different subspecies. Neanderthals in Europe, Java man in the Far East, and Peking man in China. The scientific racists, until recently, most paleontologists, or is it paleontologists, or however you say it, have taken the position that the Caucasian of today evolved from the Neanderthals. So we all know that, but in recent years, a new prevailing theory among anthropologists have emerged. This view consent that all humans alive today are descendant of one woman who lived in Africa sometime around 100,000 years ago. According to this African Eve theory, a wave of human migration came out of Africa in about that same time and replaced all other human species that existed throughout the world, including Neanderthals. All right, Neanderthals turned out then to be evolutionary cul-de-sac that did not evolve into modern Caucasian. In short, Neanderthals were replaced by modern humans from Africa. So just to read a little bit of that information, you can go ahead and check that out for yourself. The African Eve, the new confirmation that we all came from Africa, and this was written about 20 years ago. So I'm not gonna go any further. If you guys wanna read it for yourself, you can. So maybe some of it might be outdated because it was 20 years and 21 years when this source came about, but some of it is still relevant. And what one thing has confirmed that we all come from what they call the Monacondrial Eve and whatnot. So, all right, let me go ahead and let me see what this is. Okay. All right, so I'm not gonna read the last one, but if you guys want to read it yourself, you're more than welcome to do so. That's on your own personal time. But anyways, this one comes from the Columbia University Press. Chapter titled Mitochondrial Eve and Y chromosome atom. Troublesome science. So misuse of genetics and genomics in understanding race. Okay. You guys, you can look up this article. You can just go on Columbia University Press and type this in if you guys want to read it for yourself. I'm not going to really go into it, but yeah. So it just goes into that whole Mitochondrial Eve and Y chromosome DNA. All right. So in our conclusion, to break up this information, we all have this mitochondrial DNA, all of us, both male and females, but it's that the women can only pass it down from one generation to the next. That's it. That's all the women can do. They don't have the Y chromosome, which is the Y chromosomal atom. That is only the male that can pass his Y chromosome DNA. That's it. So basically, the whole story about this Eve gene or Mitochondrial Eve is the telling of the story about the earliest form of humans, which are the Homo sapien humans. That was around approximately 300,000 years ago. So that's the story about that. Again, to get more details about it, you really have to take a time out to actually do the research and actually read on it. And there is plethora of books about Mitochondrial Eve. Plethora. I mean, you can find them on Amazon. You can go on Scribd, which is an app where you can look at audiobooks. You can download ebooks, documents, all that great stuff. So it's a lot of information going to this. What we're dealing with is genealogy and biology. That's what we're really dealing with. That's the type of subject, because it's more so biology, because that's just like, it's very complex and to get into genetics and the genome and all that stuff is very complex. But yeah, this was brought to me by a request from a family member to do this video about the Eve gene. So hopefully they are satisfied with the video. I mean, I did to my best of my ability. I didn't spend a long time on it. But yeah, so basically that's what the whole concept about this topic is. I hope you guys enjoyed it. And I thank you all for watching the video. And if you want to, you can share this. You can share the video, share the content. Make sure you guys subscribe to the channel, hit the notification bell whenever I come on. And that's it. With that being said, I'm a little tired. Okay, thank you, Sabrina. Yeah, I couldn't even get it out the tip of my tongue, you know. It's paleontologist. Yeah, paleontologist, whatever. So you guys have a wonderful evening, and I will stay connected with you all sometime this week. You know, normally you guys can catch me Monday and Tuesdays doing these videos and going into the topics. So yeah, be on the lookout. All right. Until then, peace. All right. Yeah. Have a good one. Thank you. Oh, I was going to say, if you want to really learn more about science, please check out the Team Osiris channel. Check out Team Osiris and check out Brother Ngozi, because Brother Ngozi, he goes into this in more detail better than I can. Like, he's a science expert, so he can tell you this from the top of his head. That's how intelligent he is. He knows more about it better than I do. So if you guys want to learn more, you guys look up Ngozi name, Ngozi, Ngozi. Look up Brother Ngozi, Team Osiris, and he can explain the whole concept about the Mitochondrial Eve, genetics, and all that great stuff. So as a matter of fact, we got the channels up still, so you guys can go check out our channel and look that information up if y'all want to and whatever. All right. Anyways, y'all have a wonderful evening, and I'll check in with y'all next time. Peace.